Okay, so this is the place from where I was broadcasting so far. This is a big table that we have. We're sitting opposite to each other with Tomáš, and all the people who are working with us are sitting at this table or on the window. This is the main room where we try to create all our designs, and we also make our own brainstorming meetings here, and we are meeting the clients in the other room that you saw, and there are more rooms here, and other people are working here as well. This is sort of a co-working space, but we are trying to select people who are sitting here with us so that we know that we might eventually collaborate on something together at a certain point. So this is not a random selection of people. There is a programmer who is working with us on most of our projects. There's a photographer who is taking all the amazing pictures that we have. There is a graphic designer with whom we wish to collaborate at a certain point. We also keep some prototypes here. Not all of them, because some of them are really big, so we keep them in a storage room outside of the city. But you can see some stuff. So we do have a 3D printer, but we don't use it that often. It's this one, but we have printed a couple of prototypes here, just like you can see. All the formal experiments where we wanted to know if something like this is printable or not. All the pieces that we have left from, for example, the ornament that we are going to show later on today. We also made small 3D printed models of the models that we made for our client, just to show them how it's going to look eventually, and all sorts of material prototypes like these ones, for example. It's the same building, just in different material. My camera keeps going on and off, so I need to somehow switch it on to see what am I actually showing you, like this. Okay. You can also see that we have a lot of workout equipment here. It's not that we would be that into fitness, but we made a project that Anna is going to talk about called Edit Part. And it's a storage rack, a design storage rack for workout equipment, and you can see the prototype here, also some other equipment around here. We also have a lot of projects that we start but never finish or deliver because either it's cancelled or we just make a proposal and it doesn't go through, and so on. So, but we still like to actually produce some prototypes out of that to actually make sure that we can produce the thing properly. And one of them is this one that Tomáš will talk about later on. So also we make sure that whatever we are proposing to our client is actually viable. We can do it. We can produce the thing. There's another one that I would like to show you here on the other wall. It's this one, like that. So this is the work environment. If you're asking where all the people are, we decided to, we thought that they should take a week off. So they're not sitting here with us today, but starting from Monday, this will be a full house. Maybe we can talk about that a little bit later. Your sound isn't good. Yeah, okay, so at this point I can switch to the headset, and I'm pretty sure you're going to hear me better. So I hope it's better now. And I will also switch off the camera very soon. So anyway, I just wanted to mention that starting from Monday, we are going to work on a 3-month-long research project here at Subdigital. It will be partly the Subdigital project and partly research project. So we've got these two brands that we like to combine very often. And we invited or selected a group of interns who are going to work with us. And if we manage to actually bring this to reality and conduct a really valuable research,
then we are going to use what we have researched in practice. First, we are going to make a couple of exhibitions out of that, and then we will do our best to incorporate that stuff into our usual workflow. So when I was mentioning that I think it's important to have a long-term agenda, now we are going to work on that long-term agenda with the interns whom we wish we will teach something, some things, and we hope they will teach something us, because they are coming from different backgrounds. We are still looking for some people to join the team, and we are hoping to have a multidisciplinary team. So we are not only interested in architects or students of architecture, but also other creative disciplines, arts, design. We wouldn't mind to have a musician here, but we also can use all sorts of technicians, like machine engineers or IT experts, programmers, but even electricians would be nice to have here. But eventually, it seems like architects are now very multidisciplinary. So most of the people that we have here have more than one expertise aside from architecture. Okay, so maybe we can talk about that project later on if we still have time. Now I will prefer to switch off my video, and I would like to show you how are we actually planning to, or how do we promote what we do, and how do we communicate. I will start with a website. I will share my screen instead of the video, just like this. Okay. So we've got a website that is kind of unusual, because you only have to type sub.digital. There is no .com or any national domain. So it's sub.digital. And we started this website 2 years ago when we didn't have that many projects finished. So just like it's usual, there is a promo video. I would like to talk about the videos a little bit more. We have some claims here, and then we are showing the projects. The thing is that the reason why I'm showing you in that much detail is that it would be incredibly useful for us if you can give us some sort of a feedback about how do you actually feel about the way we communicate the stuff, because we've already spent some time together at this workshop, and I hope that I know that you understand pretty well what we are up to and what we are trying to achieve, but it took you a couple of days to actually delve into that, and we don't have that much time with our potential clients or potential collaborators to actually explain to them in detail what are we doing. So any sort of feedback would be incredibly nice to have from you. And that's why I'm showing you all the stuff this way, or we will show you the stuff this way. During this pandemic, we designed a shield that can be produced really fast. This is not 3D printed. It's a laser cut or CNC milled or CNC cut. It's a shield that can be produced in an amount of more than 100 pieces per hour. So in fact, instead of just 3D printing one shield for 1 hour or even 3 hours, depends on the design that is out there, you can actually in the same time produce 100 pieces like this. It's an open source project, so you can download the files and you can then produce it yourself. We even have blueprints for making one with just a pair of scissors, so you don't really need to use any advanced machinery. But speaking of that, I will go a little bit back. The website now has a list of projects that we have finished. This is certainly not the entire list, but that's what we were able to put together on a website. So for each project, when you click the project, you will have some overall image. Then you have some details where we are explaining why the project is interesting, and then you can see it in use, and then you see some technical drawings. Anyway, so let's go back. I will not talk that much about the website anymore, but you can also see a catalog here, which is an English version of like previous version of a catalog. And that's the thing that we spent almost a half a year now just working on this catalog, and the version that you can see here is not the final one. The final one is the one that I'm going to show you, but unfortunately that one is not in English. But now the content is, I believe that it's much better, and also it's better delivered. So let's go there, and we can talk about the project. And also, we will try to explain on each of the projects what was the thinking behind, why did we think that it's a valuable thing to do, and so that's something that is internal. And also we will tell you what did we actually communicate to the client, and what was the thing that the client actually appreciated. The most difficult part, as you could see in the previous blog, was defining who we actually are. So this heading says who we are. And we say here that in the creative studio Subdigital, we are connecting or employing the computational technologies into the creation of architecture, design, and art. We are producing sophisticated material objects that embody the visions of our clients. So we are basically telling people that it's if they want to communicate something that is truly theirs in an advanced way, we are the ones to talk to. So this is the core team that we have. It's me and Tomáš on the right side, and Kristina Uhrova, Michaela Krapalova, and Ján Tolt, who are working with us long term. Kristina and Michaela started with us as interns, and we are happy that they stayed. Kristina was supposed to be here half a year. Then she is actually not from Slovakia. She's from Czech Republic, which is not far, but still is a foreign country. And she stayed here for 9 months. She decided to spend the pandemic here, and we were lucky. And she is coming and going ever since. And we've got some former members of the team. And we've got some new people coming, and Ján Tolt is our programmer who is developing the software, mostly with me, but sometimes alone and sometimes in an extended team. We do combine 3 things. The main thing is the design and architecture and arts. We combine it with the digital technologies, and also with the fabrication technologies that are also kind of digital. So if you take all 3 things and combine them, that's what we do. And it's a strong simplification of what we actually do. And we hope that this is something that is easily digestible, easily understandable, that we are designers, but we are deeply into the digital realm as well. This is a process that I was showing already, and one of you was referring to it before. We are now explaining what is the difference between the conventional process and the digital process. There's one thing that I would like to point out, is that in the conventional process, you need to make notation blueprints or drafts or any sorts of documentation, so that people can actually read it and produce the thing for you. So basically, you've got some workers who will take the plans, look at them, and do something. In our case, mostly we don't really do it that way. We just produce some digital data that our partners are then loading into their machines, and the machines there then are producing the stuff. So we don't have to make that many annotations. We don't have to put dimensions on the drawings, but at the same time, we need to make sure that the data is viable for the machines that are going to produce the stuff. So now we have 3 groups of products or work that we do. Just bear in mind that this is only what we've been doing in the past 3 years. What we have done before is not branded Subdigital, it's branded research, and we haven't put it into this presentation. So the presentation objects are the first group of things, of products that we actually make. It's probably the least interesting one for you in sense of computational design, but those are the ones that allow us to run the studio and to make the experiments while we are producing something. Then the second group is architecture, exhibition, and design. And the third one is some sort of support in the parametric world, which means education, and we are also doing some stuff for our clients, like whatever we can do with the parametric tools, we can do not only for ourselves but also for the client. Now, let's go through the presentation objects, and this is something that maybe Anna could talk about a little. I will just give you a very brief introduction. We had a client who was who is a real estate developer, and they are building the tallest building in the country. It will be the first skyscraper, which is measured by the height, and it's 150 meters tall. And they wanted to have some sort of a presentation tool to actually show that building. And we decided to, and first they were looking for some hologram or for some advanced way of showing things, but the technology of holograms, it's not really existing yet. Then we decided we will make a sculpture instead of just a usual model. Which means that we simplified the design that they gave us a lot. And we proposed something that will be made of metal and glass and acrylic, and that will also contain some interaction and interactivity. And this is we are putting only the photos into the catalog, so you won't see any renderings here. So this is a photo as well. We knew that we want to make a nice promotional photos of this project. Therefore, in the last stage, when we were assembling everything together, that was done in a photo studio. So we rented a photo studio for a week, and we spent a week there putting everything together and making sure that everything works. It was some sort of a rehearsal, if we can actually, if all parts fit together. And at the same time, there was a photographer who was taking pictures and videos of the process and of the final product. Maybe I would like to ask Anna to step in and maybe talk a little bit more about the project, and I will just go through the presentation. Anna, I will show you the rest of the pictures, because I think you haven't seen this presentation before. So just that you know what to expect.
What I'm talking about.
Yeah, so this is the cover picture. Then we have these pictures and information. Then this is Anna standing in front of it. Then this one, and that's it.
Cool.
So
okay.
Let's go back here.
So I think I joined Subdigital actually at a point where this was already a project, but I don't know the genesis of the project maybe as much, but then like the client part of it. But I came in when it was sort of the prototyping period of the phase of the project. Should I just describe how the whole process worked, or?
Yes, I think so. You could, whatever you need from me. If there is any gap, something that you would like us to say, just tell us.
Sure. Well, I think it's a challenge to build such a large model, which is so technologically advanced that you actually like have to build something out of thousands of little pieces. The first phase that I remember was actually prototyping one single floor of the whole building to see how a floor is gonna work, or like maybe 2 floors at a time. So we see how the 2 floors are connected. But the idea of the tower is that there's a light source in the middle. So there's cables and like the whole I guess a technological background is in the middle of the tower. So the tower is kind of hollow, and there is LED strips running through all of the floors, and there's sort of separate strips that are separately cabled to a source that is then connected to computers, and then the computers are actually all hidden in the base of the whole model, in the plinth. So here I think the challenge was one thing is that how the tower will look like, what are the little pieces of each floor, but then also how it works as a whole, as a holistic kind of project, so that it's not just a plinth that holds the tower, but also a plinth that is functional in a way that's actually, let's say, hiding some of the technical parts of the project, but also being a sculptural, aesthetical unit of its own. So the first challenge was definitely how the electrical bits are going to work. Even I think at the beginning we didn't even start with the whole program, which I guess the software part will be more like Ján's bit, that he'll talk about it more.
For
but
sure.
the just how the light is going to light up on one of the floors. That took us like a month or two probably, because there's so many things that when you think of it first, if it's just a thought experiment, then you don't think about those details. And once you start building it, then you like run into all these little things. And I think it was a lot about how, like, which material of perspex or like acrylic should we use? What should be the finish of the acrylic? Do we need a diffuser for the light? Or if we need a diffuser, how far should it be from the source of the light? And all of these little steps that we had to sort of, we knew that they would probably happen, but then once you start doing prototypes, you realize how little changes can make huge differences. And then just generally how to build up a floor, which consists of like 5 to 10 separate flats, and you have to be able to control later on each separate flat to turn on and off. So how to separate them with dividers and like so-called walls, so that the light wouldn't leak in from one flat to the other. So these were the challenges of like designing the whole building. But then once you sort of solve it in one flat, and then you have to build, how many floors are there actually in total?
It's 45, 46 maybe.
Oh yeah, okay. So I think it's about like 30 of them were like similar, and then the top floors were getting narrower and smaller, so then each floor was unique. So I remember that's when the sort of digital tools came in, that we didn't have to draw all the little bits of each floor, but we could actually make a system that would generate the parts of each floor. Do you want to talk, Ján, more about maybe how we use this tool of like generating the bits?
Maybe I can. I think it's also important to show how the building, we didn't make the design of the building, we just made the design of the model. I just want to show you some renderings. So when we were starting, these were the renderings, and we thought that we should make it a little bit more simplified, and also the design should be a little bit more subtle than the real thing, just to show the overall shape and so on. I also want to show you the first sketch that we made. It's also kind of important to say that here we just heard that they are looking for, that the client is looking for something, and we really wanted the job. So this is a super quick rendering that we made maybe in a day or so. And then for the rest of the time, we were trying to achieve something that looks more or less the same like this one. Looking back at this, I think what we actually made is looks better than the first rendering, but it's very close to it. So the tools that we were using is like, for each of the floor, we made a grasshopper definition that was chopping the whole thing into the overall model into floors, and putting the partition walls where they should be, and so on. But all these grasshopper definitions, they were just partial tools. That has to be said, that we didn't make one large grasshopper definition that would generate everything just in one click. There are many small parts that made the big thing work together, and in between there was a lot of manual work. So still, all these digital things, when it comes to building them or making them real, there is a lot of manual work that has to be done. But I think there's an important thing that we can actually show here or talk about, is that you can use Grasshopper not only to generate things, but also to do the quality control for you. And I made a free tutorial for that, which is called GHLint, and it's based on this experience here. So we actually made a couple of Grasshopper definitions that were running in the background. So we were not really running like using it to produce something, but they were running in the background. And while we were drawing and making the 3D model in Rhino, Grasshopper was constantly checking if everything works. And if there are no collisions, if everything fits, one part fits another, and so on. And here we didn't really use the tools to generate new stuff, but to actually optimize. And this is based on on experience that we had, that when we first made the first drawings, Anna was working on that. Then at that point we realized if we start producing this out of steel, out of acrylic, out of glass, and something doesn't fit, then it's going to slow the process down significantly, and also it's going to mean increased costs. So at that point, we decided we are going to have a very strict review process. So each time there was a new version of the data, of the drawings, somebody spent a day or two just checking if there are some mistakes or not. And at this point, we developed the process where everything has to be reviewed. Everything has to be checked by all the team members, or well, at least some. So anybody who is available currently is making the quality control. And we found a lot of things that that had to be changed, and otherwise one person would never think about those. So for example, if you look at the ribs here, they were the last thing to assemble to the entire tower. So you see that we are building up the tower without the ribs, but we had to, through the review, we realized that it might happen that there is not enough space to put the rib in, although it fits in perfectly, but the process of putting it in requires a little bit more space than just being there. So we were thinking about these things as well, and we started developing the digital parametric tools to actually do the checkup for us. But we also did the human part of checking things up.
Yeah, I just think it's worth highlighting that drawing all the bits manually, I mean digitally but manually, would take much more time than using these partial tools that Subdigital developed within the project. No, like
sorry, Anna. I just wanted to contribute something to the ribs.
Yeah.
But continue. I didn't want to interrupt.
No. That's it. I think you should explain the ribs. Sorry.
Okay. Well, I wanted to continue about the layered structure of the tower and the ribs. Actually, ribs were the most problematic part, because all the pieces we were doing this quality check and precision check, and we were able layer by layer very precisely calculate the thickness of the laser cutting, and we were able to predict how these pieces of each of the floor would fit. But actually, it was not easy for us to pre-calculate how, when layering 46 layers of these floors, how this layering would count all together. Because when you layer so many pieces of metal on top, the complete thickness is not exact addition of the thicknesses of all of them. So actually, the the latest adjustment to the whole building process and the fabrication process was that even after we finished building the whole model, layering all the 46 floors, we were able to precisely calculate and last minute fabricate the ribs. We were prepared for that because we had a process that generated the ribs for us, but we needed that one last input that was the actual height of the building. That was not predictable in that quality check.
This is also important to say that when you are producing something for the real world, you need to take into account all the imprecisions, and here the error was accumulating. Okay, Anna.
Yeah. Should I tell more? No.
Maybe we can move on to the next project.
Yeah. I just remember the building, the project was a kind of a team building, and it was very much fun, as you can see this last picture.
We spent a lot of time with the manual labor, actually, and you see that. Well, the thing is that one important thing is that everything that we do somehow weighs 350 kilos. So it's quite heavy, and it's always 350 kilos. And we also do a lot of weightlifting while actually producing something. There's one more thing I would like to tell about this project. You cannot see it, but there is a computer hidden in the plinth. Actually, not one of them, but 10 computers. 9 of them are microcontrollers, like very small computers that are controlling the LED strips that are inside. And we made basically a custom system of LED strips that altogether create a display that is wrapped around this tower. But in principle, we could put the LED strips anywhere in the space. They are perfectly mapped. We know exactly at which position they are, which direction they are looking at. And we made a custom software that is generating a lot of different visual effects for the tower, for the LEDs. So we can simulate clouds, we can simulate the sun path. And then, of course, there are very useful things like we can highlight certain apartments, and it's all connected to the internet and to the database. So the client can see in real time which apartments are already sold, which are available, and so on in different colors. But also the software that we made, we usually start from scratch. And it was made exactly to work with this tower, and there's a lot of geometrical thinking behind the software. One last thing about the project: if you go to our website, which is here, I will just put it into this window, so you can find the project here, and there is a video that the photographer Petra Ryabinin made with music by musician named Strun, and you can see how do we present the stuff and how does it actually move and what does it do when you operate it. And there are also some schematic views of how all the things were assembled together. All right, I think we shall carry on and we will make it shorter for the other projects. This one, again, was a presentation model for the same client, and they were actually proposing that the city should build a new tram line, and they will contribute to the tram line. They made all the projects, and they wanted to show that their solution is the best for the city. So they needed to have a model of the entire city, where they would show on an animation that this is the path of the new tram line. First of all, this is also interesting to say that with this project, they approached us as a 3D printing company. They somehow thought they saw another project of ours and they saw, okay, these people are 3D printing. So they can 3D print something huge for us, and this is not true. We don't want to be model makers. We've got only a small 3D printer. We don't have the technology. We are designers, and we have collaborators that help us to produce something. So we talked to the client and we said we think this is not the best solution for you, and we can propose something better. And but they somehow insisted that they want to have a 3D printed map. So we made a couple of test 3D prints with various companies, and we were lucky enough that they didn't turn out well. And maybe it would be possible to 3D print something this big, but eventually it didn't turn out okay. Now, just to give you a glimpse how big this is, in length, this is 2 meters, in width, it's something over 1 meter. So instead, we proposed that we will make a hologram for them. I said holograms don't exist in the previous presentation, but here we came up with a solution. And again, we made a lot of prototypes. I think at this stage, it was like 5 or 6 different prototypes of just the technology or the thing. How do we want to show the map in a hologram? And I can show you here. We decided to stack a lot of layers of perspex, transparent plastic boards, and each of the boards contains an engraved layer of the city. So if you look closer here, I cannot zoom in for some reason. I will just do it this way. Here I can zoom in. What you see here, when you glow a light inside of these boards, you can see the engraved layers. So what you see here is an actual 3D shape of buildings inside of the of a pile of something that looks like a glass. So when I zoom out, you can see that this is what it looks at the edge. And also this is how it looks completely. So there is a hill here, and that's also 3-dimensional. So there are things floating somewhere in a pile of glass. And there is an animation underneath that is showing the tram lines going, the new tram lines, and so on. This also weighs 350 kilos because the perspex is so heavy. And we also made sure that everything is consistent when it comes to the aesthetics. And also we made sure that there is some sort of parametric design. And I can tell you which parts are parametric here. There is the plinth that maybe Tomáš can talk about a little bit, but before I will just tell you that we used Grasshopper to produce the horizontal layers for the engravings. We also simplified a lot, and also the entire animation that is a couple of minutes long. It's made with Squid, which is the plugin by Mateusz Zvierzycki that I was showing you a couple of days ago. And that was incredibly useful because we just made a parametric tool that exports the animation, and then we could change the content according to the client's needs. And we could have done it from input that was done in a CAD software. So in a construction technological software, not software that is used by graphic designers, because then they would have to redraw everything, and we didn't have to. We just took all the drawings that they gave us from AutoCAD or whatever it was. I think it was AutoCAD, and we imported it into Rhino and exported everything into using Squid into an animation like this. Maybe Tomáš, you could say something about the plinth.
Yeah. Okay. In this model, you can actually see exact that thing that I was describing at the first lecture we had, that each of these projects has a layers. The display and the layered holographic city was the layer that was necessary to achieve to satisfy the need of the client, and that gave us freedom and possibility to do our own design of the plinth, which was challenging, which was a thing that we try to apply our formal agenda to. So this whole idea of a shape for this plinth of the model came from you can see on the lower left part of the screen, you can see the formal sketch that was working with cutting a piece of or block of mass with a lot of lot of planes, and aligning these pieces in space in a way that there are gradients in angles and rotations that are changing slightly between the pieces. So this was the first formal sketch or formal idea, and we wanted to apply this to a plane which would be light enough, because we had a lot of mass happening in the upper part of the model. And of course, it needed to be stiff enough to hold everything and not to shake somehow, because we knew that this model will be placed in a public space, and even though we don't want usually people to touch this thing because it gets destroyed, we know that it always happens. So we cannot rely on not having something stiff. So that idea of multiple layers that are changing their orientation in space gave us also a very good structural capacity of the whole structure, because we were able to achieve a structure that wouldn't fall as a dominoes. If we use the design that would consist of planes or frames that were oriented the same way, just having them aligned under the model, the structural stiffness wouldn't be sufficient, because it would be very loose in one direction. So we used the visual or formal capacity of this kind of gradient in orientations, also in structural ways. So we were able to achieve very good stiffness.
All right, let's move on to the next project, which is the largest one that we made, but I will make this much shorter. This is the one. This is our flagship project so far for the commercial clients. This is a huge map of the same city, of the city where we are at now in Bratislava. This is actually a physical 3D model. It's 3D printed partly, but also there are other technologies used. But the model is transparent, and it's put on 3 large flat screens. Each one is has a high resolution, and there is an animation playing underneath. And it's not it's not a hard-coded animation, but it's being interactive, so it's being created in real time, and the user can control it. And I will show you a couple of interesting parts of this model that I think are worth mentioning. First of all, there was no display that we could just use out of the box. We had to completely disassemble existing displays, which is a complicated and expensive equipment, piece of device. And we just disassembled everything to the bone and built it into a new frame, which is the one that you can see here, but also that has certain thickness, and we didn't want to have the thickness there. So you see that it looks very light and thin, because we use that trick where we layered a couple of layers, like the wooden layer is on top. The wood is there because the client knows that the showroom where they are going to show this is made of the same wood. And then there is a layer of glass that is underneath. You can see it here. And then there is another layer of steel that is slightly inside. So it starts somewhere here. So when you're looking at the model, it looks incredibly thin because all the thickness is somewhere deeper. Also, there is a very, very powerful computer hanging from the middle of the model, so that when you're standing next to the model, you don't see it. And the entire thing is standing on a system of legs. This is a plinth that supports the whole thing, and it's super lightweight. And this model, we are servicing everything all the time for the client. And after a year after we finished this project, the city has changed so much that we had to replace half of the city. And also we replaced the plinth for a new one that is made of parts, because it showed up that this is going to be transported very often. So we transported this model for at least 5 times or maybe even more already. So there's also the disassembly process and so on. I will show you some more details. One thing that we are kind of proud of is that you can control it using an iPad, but the iPad can be charged directly from the table, from the plinth. So there is an engraved place where you just put the iPad and it starts charging. It's got a magnetic attachment point, and it seems like part of the whole model. As I said, we are transporting it very often. So we went to a real estate fair in Cannes in France 3 times already. It was exhibited at several exhibitions, and the client moved from one building to another already, and we moved that thing as well. So we were disassembling and assembling the thing many times. Also, we knew that this is going to happen somehow, so we manufactured a lot of transportation cases for every piece, and everything is has a mark, and we know where to put each one of the pieces. So if you look up close, it looks something like this, and there are buildings made of 3 different materials and 3 different technologies. Some are just laser cut, some are 3D printed and then molded and cast out of a different material, and some are combination of these two. We are making sure that everything is in high detail. So even though the model is in the scale 1 to 1000, the detail is somewhere around 1 to 250 of the usual detail scale. And when I was showing you, when I was holding the camera, when I was showing you the experiments and the prototypes, we were prototyping one of these buildings. It was this one, just to see what material works the best and is the most persistent one. And what you can see here is the animation. So when there is something on the screen, an animation, it actually changes the color of the buildings that are put on top of the displays. And you see that each building looks different color, but in fact we can change the colors and we can change the animation according to the needs of the presentation. I also have to say that almost half of this effort at this project was the software that runs underneath. We made our own animation engine, because none of the existing ones would be able to power 3 screens that are 4K resolution. So it's a huge resolution, and we needed to animate every single pixel on the screen, and we needed to make sure that it works well and fast. So we made our own software from scratch. And it allows the user to take the iPad and change the animation on top of the screen, and it's made of layers. And you can imagine just layering effects one on another, and you can individually switch on and off 175 different effects, and it still performs well, even if all the effects are turned on at the same time. And we are also making sure that everything is slightly animated. So even if there is a green color to show that there is a park, it's moving slightly. When there is water, it's slowly moving as well. Even if there is just one color underneath the buildings, it's pulsating a little bit. And speaking of the animation effects that we can turn on and off, we can of course show different districts of the city. We can show different buildings that belong to our client. They can highlight their own buildings. We can then highlight what sort of function each of the building in the city has. We can highlight amenities like cafes and supermarkets and cinemas and things like that. But we can also simulate transportation, and that's something that we also made in Grasshopper. We exported transportation paths of the real buses, trams, and all these public means of public transportation. And it's actually showing the real paths and real trajectories and bus stops. And we used Grasshopper to produce all the data for our own software. So the process was that everything was modeled by hand. Well, first it was imported using ELK from public sources. Then everything was remodeled to be able to manufacture it. And then it was, we made, in Grasshopper, we made custom exporters that saved all the important data into our own format. That was then opened by our own engine that is animating everything. I also have to say that it's got a lot of other functions. It can be updated online. The client can change almost everything, starting from the colors that it shows, all sorts of annotations that show on the model. And there is something that we call a legend, which is some sort of text information about what you're looking at. Mainly, it is bound to the effects that the client can turn on and off. On the iPad, we can remotely maintain it, so we can troubleshoot stuff. And there is also a supplemental additional screen that shows some slideshow that is showing stuff related to what is highlighted on the model. There is also a parametrically designed plinth, which is also, the principle is more or less the same. We made sure that it's stiff enough, but it also looks very lightweight and looks kind of exotic. We are mostly, when we have pragmatic assignments, we decide to design, to leave the top according to the expectation of the client, and whatever is underneath, like whatever is under the table is our domain, and we get a little bit crazy on the bottom part. I would just quickly go through other projects. This one will be super short. There is an animation of a section. It's here. It's a section of a building, and the client wanted to show that there is a lot of stuff happening inside of the building throughout the day, and they made an animation. We didn't make the animation. They gave us an animation, or together we defined the animation. And there is a story in this large bubble of a person coming in, spending the workday there, and then shopping, and then sporting, and then having a free time in the same building. And we decided to hide the technology as much as we could, just like we did with the big model. So there is a computer playing the animation, and there is a TV screen that is completely hidden behind this wooden board. And the wooden board contains partly the section itself, but it also has some extra features here that are only showing what is inside. And we took the opportunity to use the CNC milling to actually achieve these shapes that are 2.5 dimensional, and they reveal curves that otherwise wouldn't be possible to show. And we wanted to make this some sort of a centerpiece and attractor. And usually these two models are being displayed together, and this one gets a lot of attention. We were not even expecting that it will be that interesting for the audience. Also, we were trying to make it like we cared about each detail. So we made a logo that is glowing from underneath the wood. And that was also possible only thanks to the fact that we are CNC milling everything else anyway. So this was one thing that we added there. This is not 350 kilos, fortunately, but that's one of very few that is lighter. This one is very similar to the one that I was showing before, so I'm going to skip it. And we are coming to the exhibition design, architecture, and product design, which is something that we intentionally are now going to focus on more, because we want our clients also to understand that we are just not model makers, but we are the ones that can make things happen and that can make some interesting design using the computational process. The fact is that when the clients approach us, it's usually because they saw something that we did before. So that's why we want to have our portfolio diversified, and we want to show various projects. Do you want to talk about this one? Okay, Tomáš is going to speak.
Okay, so human by design. It was for us a great opportunity to took part in. It was kind of a small competition to apply for doing this exhibition design. and as it usually is, we started with the first sketch, and then we at the end achieved something which was very, very similar to the thing we sketched at first. And we are happy because we try to follow the concept. So,
but that's not. But that also makes a lot of sense, because when we are making the first sketches, it's never just when we say sketch, it's never by hand. It's always by just making a preliminary grasshopper definition or doing something in the computer, and we are trying to be informed. So even the first sketch, for that we are thinking about how to produce it, whether it works, whether it's part of our existing agenda, and so on. So it's not just a random idea. We don't work on ideas. We work on evolutionary concepts. So in an evolutionary way, we develop concepts over time.
Mm-hmm. So the biggest challenge for doing this design of exhibition was that we were about to do an architecture of exhibition that was meant to display a lot of designers, a lot of artists, a lot of concepts that were completely diverse. We were displaying an interactive animation, we were displaying a software project, we were displaying objects that were, as you can see on the picture, that were purely physical. We were exhibiting concepts or maybe prototypes. So we need to find a coherent way of displaying all these very diverse types of objects or ideas, projects. And also we had the first installation of the exhibition was in a space that was, let's say, not ideal. There, it was not a one big open space, but multiple smaller rooms, which had different measures, and we need to incorporate everything inside. Also, the objects were very diverse in scale. So we imagined this whole exhibition setup as kind of a landscape that represents all the needs of those exhibited objects. So we knew what types of objects will we be doing exhibiting, and we shaped the whole exhibition system into the form that was representing those ideas. We were working with the idea of Voronoi, because that's a system that is fitting very well cells together, and this cellular system basically divides the space into cells that are one next to each other. The challenge was to actually achieve the orientations in space in a way that we display the objects correctly. And then the other challenge was to find also, as by all the projects, to find a way how to design these plinths or these tables that are holding the exhibition panels.
But that's something that I was explaining in the previous sessions. So maybe we can skip the logic of the legs.
Mm-hmm.
And I think we will show a tutorial in the afternoon showing exactly this. So maybe we can just talk about the process, how did we actually produce it, and we can show you also the prototypes here at our office.
Mm-hmm. Yeah, so another idea of the exhibition was modularity, because we had to reinstall the exhibition afterwards. So we with this kind of cellular way of design, we were able not only to occupy the space of the first exhibition, but it gave us a lot of freedom for reinstalling it into different combination or different system in completely different space. You can see the reinstallation in Vienna that was done early this spring, this year. All of the pieces were made or produced by combination of digital and traditional processes. We were CNC milling the plywood boards. Then there was applied direct print on these boards. Some of the boards were also engraved to be able to prepare the boards for exhibited items. And the plinths were made of iron, and they were laser cut in a very precise way. But on the other hand, they were not welded together digitally. It was done by very traditional craft way of assembling. So the great challenge here was to actually think of a system of annotation, system of way how we would be able to be precise enough when welding together actually hundreds of pieces of iron that need to be welded together in a exact, precise way to achieve the form. And maybe this is also something we will talk more in detail in the afternoon.
We'll see if we have enough time. Let's move on to another project. I think Anna was working on this project as well, right? Of course you did, but you're on the picture. Do you want to add something? No.
No, it's all right. We can move on.
Okay, let's move on.
Sorry.
But this one is the one that you could talk about. I will just give a brief introduction. This was a case when the client didn't really know what are we doing, but had a good reference on us. So he approached us with this startup that is going to be called EdiPark. We are fortunately allowed to talk about it, so it's a good thing. We can tell you. This was supposed to be, or is still supposed to be, a service that he will offer to the office-based companies, like larger companies that have these large offices with many employees. And he wanted to offer a service of physical rehab exercises. So if you have a back pain or all sorts of pains caused by sitting too much, you should exercise in a certain way. And he is about to offer this service, like exercise in this way as a whole package. So you get a lot of instruction videos, you get mentorship, you get your personal online trainer, but the idea was that it should have some sort of a physical representation in the office. So he approached us to actually design something that would be a physical counterpart to the exercise, and we came up with actually more designs, mainly made by Anna. That should actually be a rack that contains all the fitness equipment. So maybe Anna, you can take over and speak a little bit about this.
All right, but just really quickly, I think I just remember how the client, he came to us and he was sort of presenting like a regular shelf holding all the equipment, and then we took it from there and said like, okay, we need to do a shelf, but the shelf has to be like talking by itself. Like the shelf has to represent the kind of idea that it's a sports equipment. It's a sports equipment for healthy spine, or like sort of a healthy body in office environments. So I remember we started talking about like how to push the limits of a shelf. So it's not like how we know it, but sort of like maybe have something that's more, maybe not a shelf, but a rack, like something that's the inside is already on, you can see it from the outside. And I think this was the initial idea that we started playing with, like how to flip the inside to the outside, how to make the rack visible from already very far what it contains. And then the geometry came from actually like a very simple geometry of a healthy spine. And then I think we started from there playing with the whole geometry, like moving around the vertebra in like 3D, and then later on, well, I'm very happy to see this, where the project has developed since I left the company. But I think this is just sort of like a parametrically generated from the same kind of starting points into sort of a shelf environment.
Yeah, that we made a grasshopper definition that basically generates all these layers that are cut from plywood or some sort of board, and it's still following the initial idea of a spine. You can see the silhouette here, but it also optimizes the distribution of each of these elements there. And when we add something, that then it reconfigures to actually find another shape that can encompass all of these pieces. And I also have to say that at the beginning, the client didn't really know the way we work. And I'm still not sure if he understands fully, but he seems to be very excited about what we do, and he seemed to enjoy visiting us and seeing what we proposed, because we managed to constantly surprise him. It seems to us that these things are so usual and often, because my Facebook feed is full of this stuff. But for some people, this is new and surprising and exciting. And we also made sure that he understands the fun parts and the special parts about this way of designing stuff. And he seemed to appreciate eventually, even though he didn't know what he was going into at the very beginning. Let's move on. This is another project that maybe Tomáš can speak about a little bit. I'll just give a short intro. We were approached by another design studio, which is a special setup, but they didn't have the capacities to actually propose a design that we could. The studio is called Crafting Plastics, and their main thing is that they are developing a new material, plastic material that is made of biodegradable components, which means that you can compost it when you stop using the product. And they are designing their own sunglasses and plastic cups. And those plastic cups, when you leave them to decompose, they will decompose fully, so they don't even leave any microplastics. So they were approached by their client, and they were supposed to build a photo wall for an event, for a social event. They were supposed to create something in front of which people will start taking pictures. And this is the rendering that we have of our proposal. It didn't really happen, but we've learned a lot. And also that's a prototype that I was showing you before on the camera. And maybe Tomáš can speak a little bit more about this project. I will keep it on this image.
Yeah, so as Ján said, this design was meant to be a manifesto of a material that this crafting plastic studio is developing. And also this material and the material fabrication process gave us a big limitation of having these little pieces that need to be assembled together into a bigger structure, because this kind of plastic done in this way, as they are producing it, can be produced only in sheets that are maybe 40 by 40 centimeters. So this scale of material somehow limited us in a way that it defined our thinking about the structure. So we knew that the final structure needs to be an aggregate of a lot of smaller pieces. And also this material has great translucencies and transparencies, which are very heterogeneous. So we wanted to play with light and maybe somehow making mappings or animations of light working with this structure. And the basic design challenge was to actually find a distribution of these flat pieces of plastic in space, so it's visually rich and coherent, has different transparencies, and there are angles that you can see through the structure, and then there are angles that the structure is completely blocking your view. And this was the idea, that we find a system and we find a way how to make a bigger structure out of small scales that are somehow positioned in a gradient in space.
There is one more thing I would like to add to this one,
because this didn't really happen. This project was never finished because because of some reasons. We even though decided to make a prototype of the whole design, and I'm going to show you now the prototype. I did before, but maybe while I'm showing you, Tomáš could be speaking about that a little bit more. I will stop sharing, and I will just put myself into the spotlight, and then I'm going to show you the model.
Yeah, so you can see that this model, this prototype, actually has two layered structure. There are the cards, or let's say there are the little planes. They are held in place by the vertical pieces. The biggest challenge was to not to do the distribution in space. That's something which is quite basic force field shaping of elements in space, but to find a detailing and find a way how to assemble these pieces together with as less bearing structure as possible, and also to find a way how to describe this kind of joint digitally, and also then to transcribe it into 2D fabrication data, because this whole structure was done by laser cutting. So actually the challenge was that we need to translate the rotations that are not done only in one plane into laser cutting that is done that is actually 2D two-dimensional fabrication process. So we needed somehow to calculate all the intersections and estimate them how they need to be fabricated from flat material.
Let's continue. I will stop the spotlight, and I will share my screen one more time, or maybe even more times. So there is this little thing that we wanted to create for our clients and partners and friends as a reminder of what we do. So we designed a series of Christmas ornaments that you can just decorate your home with. and we put them in a little box and shipped to our friends and clients. And we thought it's going to be super simple to assemble. So we also have drawn the like tutorial how to put everything together. And the thing is that we produced 400 pieces that each one is different, and we just randomly picked 4 and packed them into the package, and people just should assemble it, and each one will then receive a different ornament, slightly different. The combinations the number of combinations that could happen like this is 400 million. So potentially there are 400 million different pieces that can be assembled together. Yeah, there was a question. Let's finish this one and we'll come back to your question. Anyway, so we figured out that once we started distributing these things, we realized that people see it as a puzzle and it's kind of complicated for them, which was kind of a surprise for me to see that people don't know how to assemble these things. And it again shows that we are somehow maybe too deeply involved in this system of or paradigm of computational design and parametric design, that for us it's so natural that we stop realizing that it might be something that is new for other people. And I will switch on my camera one more time to actually show you, well, actually it was on, but I need to do it properly to show you the actual piece, because we kept a couple. So now I will stop sharing my screen and spotlight this video, and you will see how does it actually look in reality, like this. So this is the piece. It's really small, it's tiny, and it's made of 2 materials. And we are also showing that we can produce blueprints for various types of production, and when we assemble them, they fit one to another. That's another thing with the first project, with the skyscraper that we were showing you. You need to also take into consideration that there were various materials. Each one was processed by a different supplier. So it was a different company, different tool, different different machine that produced the material, and we had to make sure that they still fit together. And here we are also trying to show that we are able to synchronize the blueprints, the data for the producer to actually produce something that fits together. And we also have to tweak very often. For each machine, there are different tweaks. For each material, there are different special requirements and so on. And eventually we embodied it into an object like this. I will come back to the question that was asked. I didn't have chance to read it. Okay, I will read it aloud. When I saw this project first time, I really like the idea of creating landscape with the displays. Just to add, it could have been really nice if you use the shadows and use a screen to show some information in digital visual way. But anyway, I really like this way also. I think this is. It's not a question. The question, there was a question if someone can ask the question. Oh yeah.
Actually, this is not a question. It was a question, just that.
All right, but was it about the large map? This one? Was it about?
No, it was about exhibition actually.
Exhibition. Okay. Yeah, I just. Oh, all right. I see. There is one thing about the shadows that I may say. With this project, one of the effects that I was talking about is actually a shadow simulation. So you can actually switch on shadows that at a certain point at an hour of a day, on a certain date in a year, and it shows you the shadows in the city. So yeah, it just came to my mind that I probably didn't say that. But there is also a question if we can ask questions, then yeah, sure, ask questions. Go ahead.
Can you explain the logic behind all the curves that are in the landscape?
I cannot understand you properly. Sorry. Could you please repeat?
Explain the logic behind the ISO curve in the landscape in the exhibition.
Here?
Yes.
Oh, sorry. I need to zoom in. So the logic here.
Yes.
Let's keep it for the tutorial in the afternoon. We'll look into this. We'll make a tutorial that shows you how to produce well, more or less the same result. Okay. We'll go into detail in the tutorial. So it's also a good idea that now we know exactly what to show. I think eventually we'll just show 2 projects, and one of them will be this one, and I don't know about the other one. We will just pick one of the recent projects that that we made. All right, let's move on a little. The last thing that we want everybody to know that we are doing is that whatever software tools we use or produce, we can also offer it to our partners and clients. So of course we use a lot of Grasshopper and we teach. You already know that we did that a lot. And the thing is that we already have some experience with teaching people from other offices and studios, and we also are able we are doing these Grasshopper definitions for others. But for us, it's also very important that they understand what are the requirements and what are the expectations they should have. So you can make a ready-made solution, one Grasshopper definition that solves everything, but then it breaks a lot, it's slow, and you just tweak one little thing and everything breaks down. So it's, for us, it's quite important that our potential partners here understand what to expect, and that we like to break the problem into pieces and to offer partial solutions. Another thing that we have done recently is as a standalone software, a completely unrelated to Grasshopper or Rhino, a software that you install and start using, which is called Urban Selector, and we will dedicate the entire day tomorrow for the Urban Selector project. So I will not talk too much about it now, but we will show you in detail tomorrow. Also, some sort of a teaser or a spoiler for tomorrow. There will be an interview in the morning. I'm not going to be part of it. The guest will be our software developer, Ján Tholt, and he will be questioned by Lucia Dubachova, who is an organizer of a new media festival called Sensorium. And she will ask him how does it feel to work with architects, because he is like a real world programmer. He doesn't have architectural or artistic education, which is usually the case for people who use Grasshopper. They are usually not programmers, or not only programmers. They are primarily designers and architects, and he's not, and he's been working with us, and I have learned a lot because we worked on a couple of projects together already, and it's incredibly enriching for me to see the way he works, how different it is from our approach, how systematic he is, how rigorous he is with his work. And also part of the review process that we have at the studio, that everybody has to, that everything has to be reviewed by someone, that comes from his experience or his working with him. Because whenever we were doing something together, mainly on this project, it was impossible for me to contribute to the project without him checking every single line, every single letter that I wrote. And only when he was completely satisfied, I was allowed to make it part of the whole project. And we are still not at this level of reviews with the design, but maybe at a certain point we'll go there, because that's a perfect device for avoiding any errors. And eventually the software has very few errors, but and the ones that it has, it can be actually found by beta testing, but it's performing really well. So there are no technical issues. Maybe there are some ergonomy issues, but we had very low error rate with the software, but also then the process is incredibly slow, and this is something that we are going to talk about tomorrow. Another thing that we did a lot in the past, even before the brand Subdigital, was some support for artists. And this is one project that we made with an artist, Yulia Yurinova, who wanted to show. So it was an exhibition at the train station from where during the Second World War the victims of the Jewish victims were deported to the concentration camps. And she came up with an idea. She had some textile pieces that were somehow referring to this fact. She had some masks that were decomposing the faces of people made of fabric, and she was exhibiting that at the exhibition. But she came up with an idea that we should we should make 3D scanning of people who are coming to see the exhibition, and we should somehow digitally turn them into people passing by and not giving enough attention to the injustice that is happening, or maybe we should somehow suggest that anybody could become a victim. So so we made a little software that was 3D scanning people without them knowing that. So when they were entering the exhibition, they were being scanned, and then the scan was turned into a point cloud, and the people and slowed down and projected on a wall, which was this glossy marble, and the people, it was slowly creating a crowd of 3D scanned people who were very, very slowly moving and somehow dissolving. The points were slowly disappearing and morphing one to another. And eventually, after a couple of people came to the exhibition, there was already a crowd of people very slowly moving and not knowing where they are going. So that's another thing that we do very often, and we like to do that stuff. We also have some installations like this that we proposed ourselves, but the collaborations are always very nice, and they bring new things for us as well. And eventually we are showing a list of all the projects that we made, and I will just very, very quickly go through it. Many of these projects are basically older than the Subdigital Studio. So let's have a look just really quickly, and then we will finish, and maybe we can open a debate then. The first one that we are showing is called Asking Architecture, which is the Venice Biennale exhibition that I did with a completely different team in 2012. Then there is a lot of stuff that I made for the Grasshopper tutorials that you already saw before. And all of these are some sorts of experiments, not just randomly doodling, but it was always exploring certain topics. So here it was the paneling and parametric processing of geometry. Here it was the flocking simulation. This was another flocking simulation. I think I've shown you all these projects before. Let's go to this one. This is another collaboration with an artist, Darina Kmeťová. I think I've shown you this one as well, but I will just briefly say this is a project where she wanted to place these papers with her drawings into the space. So I came up with a system of strings that don't intersect, they don't collide with the papers, and they have a simple system of interlocking. And it's also possible to build it. So this is a photo from the gallery where we were for a week building this up. There is a video, you can find the video on YouTube. It's called Body of the Line, about how we actually assembled that thing in that week. And the thing is that it was hanging loose at the beginning, and at the very end we just tightened all the little strings and ropes here that are on the bottom. All of them finished at the bottom. So we just pulled them, and everything came to its place. I will just maybe show you the video on YouTube. So it's like this. It's called Body of the Line. So it's probably, yeah, here we go. So that's the video, and I will just very quickly show you how did we build it up. Maybe I can speed it up even more because it's like 5 minutes. So now it's double the speed. So you see that we made a lot of marks on the wall, exactly calculated in Grasshopper upfront. Then we were cutting the strings, exactly calculated in Grasshopper upfront. You see that I'm measuring there, and I'm cutting and making marks and so on. So then somebody comes and drills the holes. Then we screw in the anchors, and then we start hanging. And you can see in the computational design process, even when you are designing and even after when you are producing, there is a lot of preparation. So for a long time, you don't see any result. And then the result comes on its own really, really fast. So you see that we started hanging the stuff, and out of sudden it becomes quick because we are hanging more and more pieces. So I will speed up a little bit more. You see that we are hanging the stuff, and it's kind of, it doesn't really have a nice shape yet, but then at the very end, we will just pull the ropes, and it all comes together when it's done. And we pull the ropes, and now there are some photos of the result, and it looks something like this in the gallery. Like that. So you can watch the video on YouTube. It's there. So then there is a wardrobe. That's the one that I was talking about in the morning. They approached us like, do it the way you want to make it interesting and fun for you. So this is a wardrobe that is a double curved surface, but still it's possible to open the doors, and the doors are flat. There is a lot of geometry optimization in Grasshopper made for this project to actually make it possible to produce something. Actually, the fun part is that the fun fact is that this is not CNC milled because the carpenter who made it, he said it's easier to cut it by hand. So this was not produced by a machine at all. It was produced entirely by a human. These are the walkers that I was showing. This is the robotic lab that was conducted by Mateusz Wierzycki. These are the models that we were showing. And there is one more thing that we do when our clients know, they might not know exactly what are we doing, but they know that we can solve digital problems that others cannot. So this was a very tiny thing. There is a high-rise building actually next to our office. We can see it from the window, and the high-rise has panels that can change colors. And the thing is that they wanted to have an animation there, but there was nobody who was able to put the animation together because there was no documentation about the panels. So they were not really connected one after another. They were just some randomly connected. And when anybody wanted to apply an animation, it was just a random noise. So we came up with a system how to determine which panel is which pixel in an animation. So we created a couple of test animations that were showing us which panel is which, and then we made a little piece of a software that is partly in Grasshopper, partly in something else, in TypeScript, that actually can generate animations for this tower, even though the panels are kind of random, and we can actually do the animation so that it's volumetric. We know exactly each position of each panel. And I also may say that this is something that we've learned when we were doing the skyscraper model. We knew how to actually animate volumetric pixels. So just like we have the tiny pixels in that model that are the LED dots, here they are LED panels, but the system is the same. We can play more or less the same animation with more or less the same software on this tower as well, which is a real building. this is the project that I was talking about right now. That's the tower. But before, there is another collaboration with an artist, Pavel Truben, who made this for the Festival of Light, Nuit Blanc, in Bratislava. And this is his installation is some sort of a DNA of a mythical animal, a leviathan. And he had the idea of how it should look, and we came up with a construction of the spine that holds it, and it's actually produced from flat elements that are laser cut, but the overall shape is exactly calculated, so it looks exactly as it was in the computer, and we were assembling it. So and also the computational thing, the interesting thing there is how can you create something that is curved in the space in all directions from flat elements, and we managed to make something like that here. And we are always avoiding the wet process, so we are never gluing anything together. We are always using screws and clicks and some hooks and so on. So this is also screwed together, and you screw together flat elements and it becomes some sort of a spiral. So that's how we designed it. We also made a proposal for an interactive display panel that looks something like this. So this one is like the elements, the strips, the rows are decomposing, unweaving, and weaving back again. This is another project that never happened, but still we think that we should build a prototype. So this is queued for the prototyping. I think I explained this one before. I think I explained this one as well. If not, I will just briefly say these are elements that have a special shape so that you can aggregate them into circular parts. So they are periodic in two different ways, which is not a usual thing. Usually the shape is periodic in just one way. Just like when you have triangles, there is just one way how to make a circle out of triangles if they are well designed. This is another proposal that we are probably going to build next by the end of the year. This is another LED project where you get just a single LED strip that is moving in space, and it's revealing parts of the space, just like the scalar field, something that I was showing yesterday, that you fill the space with some values and data, and then you can reveal parts of the data using the strip. Force field, we've done it. Herban selector, that's for tomorrow. Eddy Park, we've shown. This is something that we are not really supposed to talk about. That's why the picture doesn't show much. Herban, human by design in Slovakia and Austria, we've shown that. The flake, we've shown that. I will skip this one and come back to it. The foam table, that's something that doesn't look that challenging here, but it turned out to be incredibly challenging. We are now looking for a way how to produce a table like this from tubes or any sort of rods. The problem here is that when many rods meet at one point, like here or here, and they have certain thickness, it's very difficult to create a joint because of the thickness of the material. And that's one important thing that we've learned, that it's easy to do something in the computer. It's incredibly complicated to make it in real life. So we are now finding a way how to actually produce this out of usual elements and in our conditions. Also, when somebody is going to weld it or build it, we need to have a set of good instructions so that actually it looks the way it looks, because everything has to fit together perfectly. So that's a project we are still working on, but I think we are very close to finding a solution how to actually produce something that is this complex. This is just a proposal of an interactive object that is very small, and you can have some sort of an electronic device that is combined with a physical model. And I will come back to this one. This was our answer to the pandemic situation. We wanted to offer some sort of retractable furniture, office furniture for home office. So we came up, our colleague Kristina Ohrova came up with a proposal of something that is a pole, a vertical column, on which you have elements that can be rotated and adjusted to a certain position and flipped. and they create a home office, and when you're not in the need of the home office, you can just put it back to the wall flat, and it also should look good at that time. But eventually, because we were working on home office and we didn't have this yet, we didn't really finish this project because we didn't have good conditions. If this was finished, and if we had it at home, it would be a different story. We would be able to finish this. And this is the COVID shield that that we produced in thousands of pieces because it was easy and cheap and efficient to produce. I mean, that's more or less it. I think that's what we've been doing in the last three and a half years. Is there anything, Tomáš, that you would like to add?
I don't know, actually. You were very coherent and broad.
And also quick, maybe. Okay, Anna, anything you would like to add?
No.
No way.
No way. No, it's, I mean, great. Great work. Amazing.
It's mainly the projects you made.
Yeah, of course.
Okay, let's open this for the audience. Anybody would like to comment on what we are doing or ask a question, or please give us some help how to communicate what we do properly? That would be also incredibly helpful if you could just somehow help us with this.
Hello.
Hey.
Yeah, firstly, it was so good and great.
Thank you.
You could describe all good and like in details. It was so good, yeah. And the other thing is, it was now all clear and makes sense. What you present, what I asked in the morning, and now I kind of get my answer with your works.
Okay.
Yeah, so I really like your works, and it was make sense when Anna talking about how to describe her work in Subdigital, or what Subdigital actually does. Yeah, but I really like you are solving people's problem in a different way and in a different perspective, which is like so innovative. So yeah, good luck with it.
Thank you very much. I was actually not hunting for compliments. It's also very important for us to get some feedback, even if it's a negative one. But we are not looking for a negative feedback, of course. But we would really like to know how to improve our communication, because that's where we see that we need to work a little bit harder. And we need to keep working as hard as we do for the rest, of course. But
yeah, but the thing is now it's really hard to you know, tell something about the work which you are doing, because you know, sometimes it's the process also it's something, and if I'm not involved with the procedure and process, and I'm not really able to say something, because you know, sometimes it's not just the end product, it's all about the process itself.
Exactly. That's what we are saying all the time. Yeah.
So, and the other part is, maybe I can say a little more about your website. It's
Okay.
look stunning, and it's look like really global in environment, but maybe you can add more with your like, you know, I know you are doing something with an innovative way, but maybe you can add something more about yourself, like your office. In
a little bit more personal, right?
Yeah, a little bit more personal. When I saw the website, it's really great. It's like, you know, it captures you inside, but in some point, like, it's where it belongs to, like which country or which religion, like which. Maybe this is your motto, to be more global.
It is.
But,
it is.
But still, maybe in somewhere, I don't know if you want or not, but just this might be the idea. Yeah.
Okay. Yeah. Thank you for the feedback. It seems like what you're saying is really relevant. We've heard that before, and we probably could have listened better because what you're saying sounds like, yeah, that's what people keep telling us.
I have a question.
Sure, absolutely.
And firstly, thank you for this presentation. It was amazing.
Thank you.
And I'm curious about that. I also work with so much disciplines together. And I'm curious about what difficulties do so many different disciplines work together? And are there any issues you cannot agree, or how you can solve that?
Is there anything, Tomáš, you would like to say? Should I?
I will, just 2 sentences. Well, yeah, hi. There is a potential and there is a friction that once you are working with different fields, that they have different interests. So people from other disciplines maybe are not interested in things that we are. But I think this is about communication, that we somehow make an argument about what's interesting in the project for us, what's interesting for them, and we find a way together how the results should satisfy everyone. So I think we see that people have different interests, but we see it more as a potential to learn something new maybe, and maybe push our things forward, because as we said today many times, we sometimes feel that we are too narrowly focused on what we do, and I think the different perspectives can bring not only to us but to everyone new ideas and can make the things better.
I will also add something. Actually, 2 things. Very often we're approaching different professionals. For example, with the tower project, we had an electrician, a couple of them working with us, or we have a welder who is doing all the metal work for us. And with most of these people, they finally know what we are doing, and that it took some time until we understood each other, and now we understand what do they need, and they know what do we want. And as I said, for example, for the welding, we are always there, and we are being part of the welding process. But then for example, with the electrician, we had it's not a problem really, but it's some sort of an obvious thing. We came up with an idea, and to him, it looked like something that is not informed well. It means we didn't really seem professional enough for him in his profession, and we needed something from him. And the thing is that he wasn't part of the team when we were deciding about the electrical part. We just made a decision, and then we approached him and we were looking for a solution. For me, this is an important lesson, that we should include these professionals as soon as we can to actually set up the project in a right way. But at the same time, it requires some time, some onboarding time, because we don't work in the usual ways. Our routine is different than the usual routine, and then it means that we need to invite those people long before we start a project, to show them what do we do and how, for them to understand what is important for us. And as I said, with the guy who is doing all the welding for us, he hasn't been working on one project. He was working on many projects with us, and now it's clear. He knows exactly what we care about. He knows exactly what we do. So now it works. But at the beginning, we somehow had to explain to him who we are and what do we do. So that's one thing, that sometimes to the other professionals, we don't look professional enough. That's one tension that we have. Another tension that we very often have is with the software developers. We work a lot with them, and I think we will talk about that a lot tomorrow. But I can say now, the thing is that when they make a software, they always make sure that it works under all thinkable conditions. So they spend a lot of time optimizing and making sure that it's a general solution that always works. For us as architects, when we use Grasshopper, for example, we are also kind of programming. But if you think of the Grasshopper definition, you basically, most of the times you run it just once. You build up the whole Grasshopper thing to run it one time only with one set of data. So it's just one thing. And you don't have to optimize. You don't have to think too much about that the data changes a lot or somebody uses it in a wrong way. So you can make it kind of dirty. You don't have to optimize. You don't have to take precautions. And basically you put everything together using a duct tape. We've got a lot of duct tape here in the boxes behind me. So this is also how you actually build up a Grasshopper definition. When it holds, it's okay. You can use a duct tape. It works once. You get the result. You just throw it away. And this is not how the proper software engineers work. And we very often have this kind of struggle that we try to explain to them that you don't have to be that precise. You don't have to do such a great job, because good enough is good enough. But honestly, I don't know which approach is better, because what they are doing is the right thing. It's certainly the good and correct thing to do. What we are doing is certainly not the right thing, but still we somehow need to figure out. So far we went their way because we listened, and so far most of the software projects that we did, they are well made, and they are not put together with a duct tape. They can be run under different conditions. They are not just one-time project. But I would really like to test the other option on the next upcoming project. I will try to persuade them to actually do something that is quick and dirty, and maybe let's see if that works. Was that an answer to your question?
Yes, yes, sure. Thank you so much. And I have one more.
Yes.
And I thought it's European countries seem open-minded for these creative ideas. And did they support your project?
You mean a government, like the country?
Yes, yes.
In a way, yes. Yeah.
Because when I was working in Prague, I work in Umění ve městě. It's like fast in České Budějovice.
Okay.
And we work with so much crazy artists, painter and sculpture there, and we just work, and thanks to Czech Republic, I think they so support us project.
Yes.
And I saw so many multidisciplinary projects there, and I saw it so seem like your what is your team. It's like, I think it's something is correct in Europe because it's the right way, and it was so funny, and I learned so much. Even so many engineers, so many artists, also they are so much crazy. I think they're so open-minded, and we worked so much, and it was just observed.
So, yes. You're from Turkey, right?
Yes, yes.
I said that already, but it seems to me like there are so many new media artists coming from Turkey that something must be right there as well. But your observation is correct. It's even, I would say it's better in Czech Republic. We collaborate with them a lot. We are in Slovakia. It's slightly different. but and it's more difficult to get public funding, and it's more complicated. It's way more bureaucracy, and I'm kind of really tired with the bureaucracy that we have here. But at the same time, I have to say that most of the stuff that we did under the brand research was publicly funded. Some of the things were we did that for money, so that means that we were collecting money and spending it to actually do the thing without any support. So it was self-sustainable. But yes, we got quite a lot of funding from the government. Not really in the amount of money, but how many times they supported us. They usually, it's the budgets are usually very modest. It's not a lot of money, but that happened a lot of times to give us some budget to actually do something. But we haven't been doing it recently, well, actually at all. Because it's really too much bureaucracy for us. And in comparison, I might have said that even in the morning interview, that ever since we started a commercial studio, a company, and ever since we have business clients, it's so much easier than to do publicly funded projects. It's way less bureaucracy, even though the negotiations are really tough with the clients. Once we settle something down, it's done, and it's a given, and we have a proper budget for a proper thing. And for me, it's right now it seems much more comfortable to work with commercial clients, but then you need to deliver something that they need. You cannot really just do your art project like we were able to do with a non-commercial platform that we had.
Thank you.
Thank you. Is there anything else that we can talk about or discuss?
I want to talk about social media, and I want to ask how does it affect on you finding clients? Because I followed Subdigital on Instagram, and it was interesting and exciting for me as a student, and I wondered if it's attract clients and for you or not.
Yes. I believe so. I believe so. It is happening, but the strongest medium so far was a word of mouth, a recommendation from the former client. So if a former client directly tells the next client that they were satisfied, that's the most powerful thing. Also, I have to say that when we finished the large urban scale model, we made a video. Actually, I would be super happy if you could have a look at the, we've got 3 promotional videos, and we are very proud of them because they were made by professional filmmakers, and we hired musicians to actually compose music for those videos and so on. We also wanted the music to reflect who we are. So when we published the first video after we finished that major flagship project that we had, it took maybe a week or 2 until the next client called us and said, we want something similar. And so in this sense, it works. And the video was on YouTube. We were sharing it on Facebook. We saw that people were not sharing it publicly on Facebook, but then when we talked to the client, they said it was going viral in their company. So everybody in their company saw the video. So I think they were basically sending the link to the YouTube video over their internal email. That's what I think was happening. And that actually didn't happen afterwards. And we are, I don't know, you can probably see it with me that I'm not really that much promoting the human part of what we are and who we are. I'm trying to change it also with this workshop, that we want to show who we are as people. But when we were promoting our stuff before on social media, we were just showing the work. And starting last summer, we set up an Instagram account, and the people who are working with us, they are taking care of the Instagram, mainly Christina and Michaela, and also Anna was partly doing that as well. So And we hope that it builds an image of our company for the future. So if you look at our Instagram account, you should actually see not only what we do, but we are also trying to tell people more about the concepts behind and so on. So our Instagram posts are not only pictures, but a lot of text as well. And also now we are thinking about storytelling when it comes to social media. So the research project that we are starting on Monday that I told you about, I think we are going to document it also from the human point of view. So we are going to introduce the people working on that. We are going to show the work environment. We are going to show the progress and so on. So we are going to share a lot on social media. And then I will be able to tell you if that helps to actually communicate who we are and what we do, and if it brings clients. Was that okay?
Yes, thank you.
Actually, up until now, most of the Instagram posts were maybe not so Instagrammy, because Instagram used to be very visual, and we somehow decided to use it as kind of a specialized blog, maybe to deliver ideas behind the visuals that we make, which we were not doing on our web page yet. And yeah, for me, I haven't made up my mind if it's the correct way how to work with Instagram yet. I don't know. But we are not trying to be some kind of viral to do like posts just for being over there. We try to make also the content on Instagram relevant, maybe academically.
Yes, but I think the storytelling is very effective, and the Instagram is based on telling your story, and I think if you try that in a project, it will be effective.
It's a good suggestion. But then we are struggling with one more thing. If you think about how much work it is, what we do in general, plus imagine that we are trying to have some private life, plus we are also teaching, doing social media properly is a lot of work, and probably we need a dedicated person for that.